Yeah. Though we know who we are, yet we know not what we may be. So maybe I'm the one, or maybe I'm crazy. I'm from.
Back to your No Malarkey Guided Programming. This is Kalu, and this is going to be a little bit different. I'm in the back of a DD. A DD is kind of like a Chinese Uber. I'm headed to a destination, and that's my buddy over there, Kevin. Why don't you say what up?
Yo, what up?
Me and Kevin, I'm headed to Kevin's crib right now so we can set up Ubuntu and he could have his nice little configuration. But I want to make sure that I send this video off in the short time that I'm with DD with you guys. So in the last video, we were able to get a prediction model of how tall this mystery NBA player could be. So our guess was just the average height of all NBA players. That was 6'6", and that's a good prediction model, but we could do a little bit better. In this video, we're gonna bring in some extra data, the weight, and we're gonna really do some linear regression to try to see what relationship weights and data, weights and heights have. And then once we figure out that they have some relationship, we want to plot that on a graph. So let's stop talking and get going right away. Let me close this terminal and open up a new terminal. So we got a new terminal. We got the DD driver in here as well too. He's listening to all this jazz. I'm sure he thinks it's hilarious. So let's CD into our desktop. Then we want to CD into our linear regression folder. And as always, we want to go ahead and activate our virtual environment. And we want to do ls to make sure that we still have this NBA heights weight CSV. And then I want you to go ahead and write Python and then do your imports. Import pandas as PD, import numpy as np, and then import matplotlib.py plots as plt. What did I do wrong about that? matplotlib. Oh, I forgot the T right here. So get our imports right. And the first thing we want to do is go ahead and represent our data. So data equals, we want to get this pd.opencv.csv, and then our NBA underscore height underscore weight dot CSV. What did I do wrong with that? Read CSV right here. And if we're going to do this, we're going to get an error that says we got decoding. That's because we need to add this encoding. If you don't understand what this means, please watch my previous video. So we want to give it an ISO 8859-1, and that should be good. And we have our data read. So the first thing we want to do is go ahead and get our heights. So our heights comprise, we just get our heights like that, and now we have the heights. Why don't we go ahead and get our weights as well too? So we have our weights now. So weights, heights, and why don't we get our heights? Our average heights equals heights dot mean. So our average height is this, and that was just that was all of our prediction model last video. We just got the average NBA player height, and we just guessed that this mystery NBA player, he may be 79 inches or 6'6". We want to do better. We want to get the information with weights, and if there's some relationship with weights, and we just so happen to have this NBA player's weight, then we can use some sort of model, some more accurate model, some multivariable model to go ahead and predict how tall he may be. So the first thing we want to do is try to plot heights and weights on a graph, on a scatter plot, and see what that looks like. See if there's some sort of correlation or relationship there. So to do that, why don't we just do plt.plot heights. Let's do weights first because we want that to be our x-axis. Weights and heights, and then we want to do plt. Why don't we give it some labels? So y label is going to be heights in inches, and then plt.x label is going to be weights. And with that right there, we have oh goodness gracious, that does not look anything like I thought it looks. Why does it? So we did plot. Why don't we, instead of doing plot, let's do scatter. I think that's the better one. We want scatter. And then with that, let's go ahead and give it an X label or Y label again, and then do show. So that looks much better. This is just a scatter plot of every data point that comprises of both the weights on the x-axis, the heights on the y-axis, and heights is in inches. So our tallest player right here is Hashim Thabit. Our shortest two players are Nate Robinson and Isaiah Thomas right here. We have their height. They're about 66 inches and 180 pounds and 88-ish pounds respectively. So we want to figure out if there's some line that best fits this data. First off, is there a relationship here? We can kind of predict that there's a relationship. There's some sort of correlation. And we can see that this looks like a linear relationship where the more the player weighs, the taller they we can figure out exactly what line best fits this data, then we can use that line to plot a new weight and then guess what height the corresponding weight should be according to our line. You've all done this before. I don't mean to bore you. This is just basic algebra. You guys are doing it in high school. So let's go ahead and do this so I don't bore you guys enough. First, actually, why don't I'm going to close this doing Control C, see if that works. And I first want to figure out if there's a correlation here. So why don't we use NumPy for the first time? Correlation coefficient, and let's give it the weights and then the heights. And here we can see that there is indeed a relationship. This is a strong correlation, 0.82. So there is a relationship between our weights and our heights. That means that linear regression is good for this problem because there is some relationship. So with that being said, how do we find out this line, this best fit line? There's a formula I'm going to show you. So as you know, a line is just y equals 2x plus 3, for example. In that example I gave, the 2 is what's called our slope, and then the plus 3, the 3 is what's called our y-intercept. So we want to figure out the slope and y-intercept that best represents the line, and that is our best fit line. How do we figure out the slope? Well, to do that, I'm going to show you a formula right here. This formula is from this guy, Brandon Foltz. If you haven't already, please subscribe to him. This is the formula for calculating the slope. It looks complicated. I promise you it's a lot easier than it seems. So why don't we go ahead and get this formula. So this formula just says for each individual x data point, remember our x is weight, so for each weight we want to subtract each weight with the average weight, and then we want to multiply that with each y. Remember our y is height, with each height minus the average height, which is this right here. This is average height, this is average weight, this is each weight, this is each height. And then we want to get the sum of all those numbers. So first let's get this right here. We can call this the sum of, so this is right here is a deviation of each weight and the deviation of each height. By deviation I just mean how much each height deviates from the average. I'm sorry, how much each weight deviates from the average and how much each height deviates from the average. So to do this, we're going to get the deviation of the weights and the deviation of the heights, and we're going to multiply those two things together and then sum it all up. That's all this bottom part, this top part means. So enough talking, let's go ahead and do it. So first we want to get the deviation products, and that equals the deviation products. So the deviation products equals, let's see, we want to get each xi. This xi just represents each weight. Let's just do it weight. Each weight minus each average weight. And I think we already got this. Let me just make sure that we already have average weight, average height. So let's get average weights equals weights dot mean. So now we have average height, and let's go ahead and get this again. So products, deviation products equals, and we want to get weights minus average weights. Let's go ahead and put this in parentheses to make it look better. Weight minus average weight, and we want to multiply that with height minus weight minus average height times height minus average height. And then we want to do that for each height weights in zip heights weights. If you understand heights weights, if you don't understand this list comprehension, don't worry about it. Just know what this means is we're going to take each weight, subtract it with the average weight, and multiply that with each height, and subtract that with the average height, and that's going to give us a list. So with that, let's go ahead and write that, and we can see products. We now have a list. We should really call this deviation products list. Let's call that equals deviation products. It's really a list. So deviation product list now has a list of each of these, each weight times minus the height times each weight minus the average weight, and times each height minus the average height. That's what this list comprised of right here, this deviation product list. But we want to get the sum of that. So that's really the deviation products. We want to get the sum of that. So let's say deviation products equals deviation products list. see deviation products. There it is. It is this number right here. Now we want to get this right here. So this is just the sum of the deviation of the weights squared, or the deviation of the weight squared and the sum of all that. So in order to do that, let's first get the deviation list of, so let's say weights deviation list. And remember, the independent X right here, this is our weights. So weights independent list, let's go ahead and do weights minus weights average squared for weights in weights. And it says weights average is not defined. Did I not define weight average? Weights average. Oh, average weight, I'm sorry. That's right, it's average weight. So let's switch this to average weights and it should work. So now let's look at weights deviation list. And that is a list of every single weight minus the mean and then squared. So we want to sum that. So let's say weights deviation equals weights deviate equals the sum of weights deviation list. And now we have weights deviation. So check that out. So at the end, in order to get the slope, which is all that we're trying to do, we want to get this right here, the products of the deviations divided by the weights deviation. So where is that products of deviation? Deviation products divided by weights deviation. And that is our slope, ladies and gentlemen. So let's go ahead and write that. Slope equals that. Now we want to get the Y-intercept. Well, the Y-intercept, this Brandon guy is so helpful. He gives us the equation for the Y-intercept as well too. And this is a much simpler equation. This just says we want to get the average Y. So remember, our Y, our dependent variable, is the height. So we want to get the average height. And then we want to subtract that with our slope, which we already have. Our slope times the average X. And remember, the X is our weights. So average X, average weight. And that will give you, this right here is our Y-intercept. So why don't we just go ahead and write Y-inter equals, and I'm just going to write this again and write Y-inter equals this. So now this is our Y-intercept and this is our slope. So that's our equation. This is our line, 0.106x plus 55.586. Congratulations, guys. How are we going to use this? So let's say we have a random NBA player. So we know this mystery player's weight is 210 pounds. For some reason, we happen to know that. So let's say 210 pounds. We want to multiply that, as you guys know, by the slope. So 210 pounds times the slope. And then after we have that, we want to add this figure with the Y-intercept. So Y-inter. And that is going to be our prediction. So this is 77.9 inches. Let's say 78 inches. And we know the 78 divided by 12, because there's 12 feet there's 12 inches in a feet. So 78 divided by 12 gives you 6 feet. And then we know that 78 divided by 12 gives you a remainder of 6. So this guy is 6'6". That's right around what we predicted he would be. So yeah, that's, I guess both predictions were pretty good. So why don't just for his particular weight. So let's say that he weighed maybe 260 pounds, okay? So in that case, we do the weight, 260 pounds, times the slope plus the Y-intercept. And then we would predict him to be 83 inches. So again, we can do 83 inches divided by 12. That is 6 feet. And then 83 inches divisio 12 gives us a remainder of 11. So that is 6'11". Wow. Really? Man, that is tall. 6'11", really? Okay, so if he was 260 pounds, then we can predict that he would be 6'11". So congratulations, we got our best line fit, which is this line that comprises of the slope and this intercepts. So we can actually do a function right here. So we can say predict height is a function that takes the weight, and then it returns to us the slope, which we know, it returns to us the slope times the weight plus the Y-intercept. And then we can just use this function, predict height, to predict any height once we were given someone's weight. So 178, and it should be 74 inches. Why don't we write that function a little bit better? Why don't we say inches equals slope times weight plus y inter, and then feet equals, why don't we just do feet equals inches divided by, let's just get integer of inches divided by 12. And that is going to get this the feet. Let's get the inches. The inches equals the leftover inches. Let's say left inches. And we can say that is just we can do modulo of however tall the person is in inches. 12. And that will give us the remainder. So we can do return you are feet tall and inches. And then format right here, and we'll give it feet in inches. So let's see if this works. Height, we can do 200. You are 6 feet tall and 70. That did not work. That is not at all what we want. We wanted to, let's do that again. I'm sorry. I see our mistake. We have inches right here, feet right here, left inches. And the mistake we did right here was, instead of giving it inches, we want to give it the leftover inches. So let's do that again. Let's predict with 200. There we go. You are 6 feet tall and 4.8 inches. We've done a lot. We've done a great prediction. This is a good example for how to get the best fit, the best line fit. And we can do this with NumPy as well too. This is very easy with NumPy. I'm gonna just show you right now. NumPy polyfit, and we just give it an x and a y, and then this one constant. See, heights right here. And this one constant, and this gives us the exact same thing we did the hard way during doing the math ourselves. This gives us the slope right here, and this also gives us our actual y-intercept. And we can do this, we have this predict height, we can do predict heights to, let's call it a fit equals this, and then we can do predict height 2, and predict height 2 equals np poly 1d, and in here we just pass it a fit. So we do predict height 2, and we can give it 200 pounds. And this is NumPy provided way of doing linear regression. This just did all that magic we did by hand in just 2, 3, 4, 5 lines of code. It's really amazing. So this is the NumPy prediction algorithm, and then let's see our prediction algorithm. And it gives us, let's see, 76 inches. It gives us about the same. This gives us the answer in inches. We could do 76 divided by 12 equals 6 inches, and then 76 modulo 12 equals 4 inches. So it's right. We're getting the right answer. Congratulations to you guys. We've done 2 implementations. We wrote the math ourselves to implement the best line, the best fit line strategy, or the best fit line equation or formula to get the slope and the y-intercept for a line that best fits our data. We were then able to use this to then predict any NBA player's height given their weight. So in the next video, we're going to see how accurate this is, and we're going to compare this model that we use with our weights and heights as the variables versus the model we did last video where we only used the heights as the variable. And we're going to see if we can't lower the SSE that we had in our first video. If you don't know what SSE means, don't worry too much about it. It just means this error sum of squares, and it's we talked about it in the last videos, but we're going to talk about it again in the next video. So thank you very much for your patience. Kevin, thank you for your patience. You just listening here. I'll see you guys in the next video. Peace.
Financial freedom, my only hope.